try to understand this point. Two lines in the space, if there are two lines in the space, or you can say two lines in the space will be two lines in space means in 3D that we are doing in space. Will be either intersecting, parallel, one of the following forms will be one of the following forms. In 2D, two lines can be parallel, they cannot intersect at any point and can be intersecting lines. But here in 3D, they can be intersecting lines. Two lines can be intersecting. In 3D, they can intersect anywhere. If they are intersecting, second thing is they can be parallel. Third thing, which is not possible in 2D, here it is possible. They can be neither parallel and nor intersecting. Neither parallel nor intersecting. So these two, I think you understood this, how it will be intersecting and parallel, neither parallel nor intersecting. For that, I'll explain you that if we have a, suppose this is the 3D system. How you can see the lines which are neither parallel and nor intersecting. So if suppose a line is passing from this corner to this corner, means on the top roof, from the roof, it is passing from the roof. Okay, or you can leave it here. And another line is passing from this wall. Okay, got it? So they are neither intersecting and nor parallel. Like this AB line is, if you see, just consider your room. So on the roof, there is a line which is passing from the two corners of the roof, and another line is passing from this left side wall, you can say. So these two lines will never intersect to each other and they are not parallel to each other. Okay, so this is the important thing. And these types of lines are called skew lines. They are non-coplanar. They are non-coplanar. They are on the different planes, non-coplanar and non-coplanar, called skew lines. Okay, so remember this part. We will consider this part when we will find the shortest distance between the two lines. But before that, we are going to start now. So equation of a line. We have done equation of a line passing through two given points, Cartesian and vector form. And I gave you one question. If you want, we can do that question also. So the next question was find the equation Cartesian and vector equation passing through the point -1, 1 and 2. A and B is 2, 4, 5. So passing through the two given points. So therefore OA vector A is equal to -I plus j plus 2k, and vector B is 2I plus 4j plus 5k. Then the equation of a line passing through two given points, the formula is R is equal to vector A plus lambda times vector B minus vector A in vector form. So you can write in vector form R, vector R is equal to vector A is equal to -I plus j plus 2k plus lambda times B minus A. I will subtract B minus A. 2 minus -1 3i, 4 minus 4 minus 1 3j, 5 minus 2 3k. So this is in the vector form, and there are two ways of doing it in Cartesian equation form. Either you can directly use the formula x minus x1, y minus y1, z minus z1, or you can equate. So in Cartesian form, the formula is x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. So x1 is this one, x1, y1, y1 and z1. This is x2, y2 and z2. So you can substitute the values here. You will get x minus x1 minus minus plus 1 upon x2 minus x1, 2 minus minus 1 3, y minus y1, y1 is 1, y minus y1, y2 minus y1, 3, this will be y2 minus y1, and z minus z1, z1 is 2 divided by 3. This is the required equation in Cartesian form. Okay, so like this we can do it. Next part is angle between two lines. Now we will see the formula how to find the angle between two lines in 3D. Angle between two lines. So again we will have Cartesian coordinate system. We are doing it. This is y-axis, x-axis, sorry, x-axis, and this is x-axis. This one is x-axis. This one is z-axis, this one is y-axis. We have two lines. We have to find the angle between this line. One line is here somewhere. Another line is somewhere here. Okay. So we have to find the angle between these two lines. This is line L1, this is L1, this is L1 and this is L2. Okay. And the angle between them is cos theta. So the position vector of line L1 is supposed to be B1, vector B1, and position vector of line B2 is this one. So angle between two lines, what we are doing, angle between two lines. Obviously they will intersecting, then we can find the angle, and theta be the acute angle. This theta is, we are always finding in 2D also acute angle, and after finding that we can find the obtuse one also, because two lines intersecting, they will make one acute angle, one obtuse angle. So these are the position vectors of line L1 and L2. Okay. So what will be the equation of line L1? So what will be the equation of line L1? Vector equation of L1 is R is equal to vector A1 plus lambda vector B1. Correct? And similarly, the vector equation of L2 is vector R A2 vector plus lambda B2 vector. Okay. We can take any point on this line P whose coordinates are x, y, and z. So then cos theta, the angle between them will be equal to cos theta is equal to B1 dot B2 dot product and divided by magnitude of B1 into magnitude of B2. Magnitude of B1 into magnitude of B2, and it will be absolute value. Here we should not use lambda, same. We have to take another variable mu. Can take mu. Where lambda and mu are scalars, you know that lambda and mu are scalars. Lambda mu are scalars. So this is the angle between the two lines when vectors are given. When it is in vector form, this we did in the vector form. From the vector form directly we can convert into the Cartesian form. What are you asking, Sharik? Our vectors are same for 11 and 12. What do you mean vectors are same? I'll mute you. I'll unmute you. Wait a minute. Acha, L1 and L2. Okay, okay, okay. Yes, yes. R vector is the vector of any point on the line. So vector R is always, yes, he has the vector R is same for both lines L1 and L2. Yes, vector R is always, I told you, any point you can consider on the line, any point whose coordinates are x, y, and z, then its position vector is xi plus yj plus zk. Always. Vector R is always this one. Okay. This is the general point. If we are not putting, just you think over it. If you are not introducing x, y, z, how will you write the equation of this? A1, A1 is not x1, A1 is some value, B1 is also some value. So R you have to put, then you can get. Now, if they are reduced into the Cartesian means, we have to write, if the equations are given in the Cartesian form, then what will be the angle between them? So means if B1 vector and B2 vector are resolved in components, so then we can find this B1 dot B2 upon magnitude of B1 and magnitude of B2, and we can put in the equation. So B1 dot B2. So you know that how to find B1 and B2. If I'll write here, because now for Cartesian equations, for Cartesian form, Cartesian form is the equations will be given, L will be given in x minus x1 upon A Cartesian form. ABC are drs y minus y1 upon B. And here we are considering two equations. So you will take A1, B1 and Z minus Z1 upon C1. So A1, B1, C1 are the drs of line 1. Similarly, for line 2 is passing from the point x2, y2, z2, and its drs are a2, b2, c2. So then y minus y2 upon b2 and z minus z1 upon c2. If the equations are given in this way, then angle between them cos theta will be equal to same thing. If you will find b1 dot b2, so the answer is coming a1, a2, b1, b2, c1, c2. If you remember, a1, a2 plus b1 plus b1, b2 plus c1, c2 divided by magnitude of b is what? Under root a1 square, under root a1 square plus b1 square plus c1 square. And similarly, the magnitude of b2 is a2 square plus b2 square plus c2 square. Sometimes they are writing in sine theta, but for sine theta, for converting into sine theta, there is a formula which is very difficult to convert directly, but there is a formula to write. So you can remember that if we are writing in sine theta, so it is just like coming determinants. When we are doing the determinant, a1 b2 minus a2 b1, but whole square will come here. So in the numerator, it will come, it comes from the identity sine square theta plus cos square theta is equal to 1, but you have to remember it. A1 b2 minus, you can start from A1, huh? A1, this is 1, A1 B2 minus A2 B1 whole square plus B1, now it ends with B1, so B1 C2 minus B2 C1 whole square plus C1 A2 C1 A2 minus C2 A1 whole square. But once you will find cos theta, you can directly find sin theta by using sin square theta plus cos square theta is equal to 1. So rarely in some cases, because we are going to find out the cases where the lines are parallel and lines are perpendicular. So for that one, we need this one. So C1 is square and under root denominator is same, A2 square plus B2 square plus C2 the whole square. Okay. If the lines are perpendicular, suppose L1 is perpendicular to L2. That means their angle is 90 degree. Okay. So cos 90 degree is 0. Cos 90 degree is 0. So here we will put cos 90 is equal to 0. Cos 90 degree is equal to 0. This you will put in this formula. So we get the result as A1 A2 plus B1 B2 A1 A2 plus this, remember you B1 B2, you have to remember this B1 B2 C1 C2 is equal to 0. So if DRs are given, two lines we have to show that they are perpendicular. We will find A1 A2 B1 B2 C1 C2 and it comes to be 0, then they are perpendicular. And if L1 is parallel to L2, then sine 0 degree is 0. Here in this formula, we'll put sine 0 degree is equal to 0 here. So then this will equal to 0. So everything will be equated to 0. So A1 B2 minus A2 B1 will be equal to 0. So we will get A1 upon A2 is equal to B1 upon B2. Understood? We get A1 upon A2 is equal to B1 upon B2. When you equate this equal to 0, you will get B1 upon B2 is equal to C1 upon C2. So ultimately we get A1 upon A2, B1 upon B2 is equal to C1 upon C2. Means if the ratio of their DRs are equal, then the lines are parallel. So that means we can say that in vector form here, if B1 dot B2, if B1 dot B2 is equal to 0 vector, B1 dot B2 is equal to 0, then L1 is perpendicular to L2 and two lines are parallel. If B1 vector B1 is equal to lambda times vector B2, this implies that L1 is parallel to L2. In vector form, parallel conditions is this one, and in Cartesian form. So generally we are using the Cartesian form to prove that the lines are parallel or lines are perpendicular. So remember this, for perpendicularity, we have to show this one. For parallel lines, we have to show this one. Okay. We can have some questions. Just take fast pick, then I will go to the next part. Yes. Where you are asking A2B1. Yes, A1B2 minus A2B1. Yes. A1 B2 minus A2 B1. Got it? For L1 is parallel to L2. Yes, L1 is parallel to L2. A1 upon A2. B is equal to B1 upon B2 is equal to C1 upon C2. For parallel lines, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. And here it is written A1 B2. Yeah, top B1 dot B2 is equal to 0. Yes, dot product is 0 for perpendicular lines. And this is B1 lambda times B2. B1 lambda times B2. If this is if B1 is equal to lambda times B2, then L1 is parallel to L2. Okay, got it? With okay. So next 4 minutes left, but we can do one question. So question is the simple one. Find the angle between the lines. Find angle between the lines. Vector R is equal to first line is equal to vector R 2i minus 5j plus k plus lambda times 3i plus 2j plus 6k. First equation. Second equation is 7i minus 6k. There is no j plus lambda times, not lambda times, here mu you should write when you are comparing two equations, you should write mu and lambda. I plus 2j plus 2k. Okay, I plus 2j plus 2k. This is the given equation. We have to find the angle between them. So this is what B1 and this is your B2 vector. Vector B1, vector B2. So there is no role of A here, only B1, B2. So cos theta is equal to B1 dot B2. Cos theta is equal to what? B1 dot B2 upon magnitude of B1 magnitude of B2. So B1 dot B2 means they will multiply 3 into 3 plus 2 into 2, 4, 6 into 2, 6 to the 12. Then magnitude of B1 under root 2 square 4 plus 5 square 25 plus 1 square 1. 2 square 5 square. Sorry, I did wrong. I have taken A by mistake. This one B1, magnitude of B1 is 3 square 9 plus 2 square 4 plus 6 square 36. Similarly, the magnitude of B2 1 square plus 2 square 4 plus 2 square 4. Okay, so we get 19 upon under root 49 into under root 9. So the answer is 19 upon 7 into 3, 7, 3 is 21. Therefore, theta is equal to cos inverse 19 upon 21. This is the angle between the two lines. Required angle between given lines. So rejoin, or you want to take rest of 11:30. So the next class is, should start at 11:30. Okay. Take some rest, 5 minutes, 10 minutes. Take 10 minutes left rest, and then we will start.